So in this video we're going to talk about the product and quotient rules for differentiation. I once again don't have any notes, but hopefully it'll go okay. This stuff, once you get it, is fairly straightforward. I'm not going to go through the proofs of them because generally they're really not straightforward in the sense that they're obvious. They're really not, and it would take too much time, and it's not worth it. Unless you're really interested, like I was when I first learned this, you don't need the proof. Basically, the whole point is before I start this, I want to say that this video assumes that you have the knowledge of using the chain rule of differentiation, which I will make another video on soon. Basically, you have some function, let's just call it h of x, and h of x is actually equal to the product of two other functions, f and g. An example of this would be x times e to the x. Okay, this is, if you would call this h of x, then yes, it's a function of x, but it's also a function of two other functions. So f in this case would be x, and g would be e to the x. Now, this is the product rule, by the way, we're doing right now. It just amounts to, when you do the proof, what comes out of the proof says that if you want to find the derivative of, and I'm just going to drop the of x, if you want to find the derivative of fg prime, then it is equal to fg all prime is equal to fg prime plus f prime g, or fg prime plus g f prime, but there's a symmetry. Or I always say the first times the derivative of the second plus the second times the derivative of the first. So there's like a pattern going on, and that's basically it. It's basically, so if we were to take our function we had before, x e to the x, then it's the derivative of that. Let's just write it as the good old d dx. Derivative of that is following this formula. This formula right here. Derivative is it's the first times the derivative of the second. So the first is x, and the derivative of e to the x is e to the x, and then plus the derivative of the first times the second. Well, the first function is x, so the derivative of x is 1, and the second is e to the x. So that's your derivative. You can, if you want, factor out e to the x, and you will get this as your derivative. Not so bad. If we were to do another one, d dx of sine of x, cosine of x, and again, these are off the top of my head, but I don't really need notes for this. By now I've been doing the product rule for like years, essentially. So same thing. It's the derivative of the first. The first function is sine, the second function is cosine, following this notation. So it's the derivative of the first, cosine of x, times the second, cosine of x, plus the first, sine of x, times the derivative of the second, which is negative sine of x. And you can simplify this into, this is cosine of x, or cosine squared of x, minus sine squared of x, and I believe this is a trigonometric identity. If I'm not mistaken, it's no, I don't even want to say what I think it is, because I will probably be wrong, but I mean, it's not important. This is the derivative You know, you can simplify it if you want to put the identity there. It's not the Pythagorean identity, because this is a minus. If it was a plus, it would be Pythagorean. Let's do another one. So it will be, so let's say d over dx of, how about x squared ln of x. Okay, well, the same thing, derivative of the first, which is 2x, times the second, ln of x, plus the first, x squared, times the derivative of the second, which is 1 over x. Now, so you can actually simplify this to just be x, and that's pretty much it. That's your derivative right there. You can, you know, factor out an x if you want. So that's pretty much the product rule in a nutshell. You know, you could get harder problems where if you get x times the square root of like x squared plus 2, where in this case, when you do the derivative of this function, you need to do the chain rule. And like I said, this video is assuming you know the chain rule. I'm going to do another video on the chain rule. So if you do this, the first x times the derivative of the second. The derivative of this square root function using the chain rule, let's see, it's going to be 1/2 x squared plus 2 to the negative 1/2 times 2x. Then you get these 2's cancel. I'll move this x in front. And this actually gets kicked down to the denominator because of this